This is Unit 4A. It deals with the causes of static electricity, and it also deals with the dangers. Now if we start at the bottom here, everything is made of matter, and we have three key building blocks of matter: the proton, the neutron, and the electron. The neutron, as its name suggests, is neutral. It has no charge. Proton and electron do have a charge. What does it mean to be charged? It means that they can exert a force on each other and on themselves. So two electrons will repel, two protons will also repel, but an electron and a proton will attract. And arbitrarily we've decided to say the protons are positive, the electrons are negative. Now a key to understanding static is to understand the structure of an atom. We can see here that the nucleus is very massive and it's made up of protons and neutrons. The electrons are much smaller, about 2,000 times smaller, and they're very far away. This diagram isn't to scale, the screen isn't big enough. We'd need the size of a football stadium to give you a sense of how far away the electrons are. So if you understand that the electrons are smaller and they're on the edge, it makes sense that they're the ones that are going to get removed by friction, and they're the ones that are going to move to another object. And that's what we can see here. Two objects start off neutral, exactly the same. Through rubbing, through friction, the electrons move, and the one on the right ends up being negative and the one on the left is positive. And it's positive because the electrons have left, not because more protons have arrived. We can see at the bottom here more protons. The result of that is that this whole object will be attracted to this object here because they behave in exactly the same way as an individual proton and an individual electron. They will attract each other. So the key thing to repeat again is it's the electrons that move. Moving on to the dangers and some of the negative side effects of static when we have a build-up of charge, either a build-up of electrons or a lack of electrons. One of the key things is refueling. Now we can see here again the idea of an electron. It's charged, it has a force, and it's the repelling force we're interested in here, that if you had a whole load of electrons and you give them an opportunity, they will push each other away, they will repel each other. So starting on the left here, we have a plane that's been charged by friction because it's flying along, and it's full of electrons. It's been flooded with electrons. It can be the other way depending on weather, but let's stick with the negatively charged situation. Now two things can happen. If we discharge, so remove the charge by earthing the plane, which basically means attaching a conductive wire, a copper wire here, and it literally flows into the earth, hence earthing. If we then try and refuel it, there are no problems. The fuel very happily goes into the plane, no problems at all. However, if we don't discharge the plane and then we bring the nozzle up to the refueling point, we have a spark. The electrons want to get away, they dislike each other, they will very rapidly flow. Very high rate of flow gives rise to heat. So we've got heat there from spark, so you'll get light and heat from that spark. We also have fuel and we also have oxygen in the air, and this is called the fire triangle, and we could get an explosion. Over here briefly we've got some of the other negative effects. You can't really call them dangers, but so fabrics clinging, we have dust being attracted to screens and so on, and mildly unpleasant, we might get electric shocks as well. The key thing though is the refueling. Explosion happens when it's not discharged, and we have the two other elements. We get heat from the spark and fuel from the truck and oxygen from the air, and we could get an explosion.